Okay, so we want to solve the recurrence relation below. So we know that it is a first order recurrence relation. And it is in the form of Sn equals C Sn minus 1 plus a function in n. So the function is n to n plus 1. In this case, C is equal to 1. And G of n is to n plus 1. Now the solution general would be S sub n equals C to the power 1 S1 plus sigma I goes from 2 to n C to the power n minus I gi. Okay, so let us replace n. What do we have? C is a 1, so no need to write 1 to any power is a 1. But let me make it clear. S1 in this case is a 1 as well. Okay. I need the space. Now sigma I goes from 2 to n. C to any power is a 1, so I won't write. G and I, it would be 2i plus 1. That's it. And right here, 1 to any power times 1 is a 1, so we get 1 plus. Now sigma, you just evaluate by distribution. So this would be sigma 2i plus sigma 1. Okay, remind that I starts from 2, not a 1. In this case, we apply the formula adding numbers from 2 to n. So you can approach it in many ways. We can get the 2 out. Okay, sigma I is n plus 1 divided by 2. But I want to take out the first term. If you replace n equals 1, you get a 1. Okay? And sigma 1 is n, but you want to take out the starting value, which is not a 1, it is a 2 right here. So it would be n minus 1. Okay, so if you have a worry about how to figure out, let me write here. You have to know that sigma I goes from 1 to n is n. So when I started from 2, it means I'm taking one value off. I'm taking the first term off, so I took it away, which is n minus 1. And exactly that happened with sigma I goes from 1 to n is n plus 1 over 2. So because it doesn't start from 1, it starts from 2. So I'm for the starting by 1, taking the first term away, which is when you plug in a 1, you get 1 times 2 over 2, which is a 1 back. So I put it minus 1. Anyhow, the second step is just to simplify. Now you can do it in many ways. If you want to get the 2n, so 2 cancels, minus 2 plus n minus 1. You add constants and you add the n's and you are done. So here you have 1 minus 1 cancels, you get minus 2. Okay. And because we have n in common, you can factor it out. So I'll get n plus 1 right here. And the final answer would be n plus 2. So this is your recurrence relation. Now let us verify. This is not needed, but it's for fun. Just want to verify that your work is correct. Okay, so let me verify the two terms. S4 is 22, S5 is 33. S5 is 33. So let us figure out if this is true, okay? Now S4, it means for n equals 4. So what do I get? I get S4 equals, if you plug in, you get 4 times 6 minus 2. 24 minus 2 is 2. So it works. Okay, if you want to verify for n equals 5, you plug in 5, you get 5 times 7 minus 2. 35 minus 2 is 33 back. So it is true.